Okay, welcome back. Welcome back. We're going to pick up a concept from the section 3.1. We were talking about functions last time, and functions, just like birds, have different characteristics, and we're responsible to know what those characteristics are by name. And so I'm trying to keep track of time and trying to cut the videos down to 10-minute segments. So we just want to make sure that when you're answering questions, we're going to do a warm up here. Do you know this or don't you know this? All relations are functions. True or false? And if you say, I'm not sure, then we need to refresh, right? And that was using the two videos that we had this week, Professor Dave, and then the one I added myself. But this would be false. All relations are not functions, right? Because in order for a function to be a function, it is a relationship, but each input from the domain must correspond to a single output in the range. Okay, so if you got that, good job. Let's keep pushing. Some of these figures I didn't want to get rid of, so I just want to get back here. Okay, so let's take a look here real quick. In this case, right, number 65 from 3.1, determine if the relation represented by a table forms y represents a function of x. What is your thoughts? And again, this would indicate no. So you need to be able to also to explain, right? So why would you say no? Well, this relation is not a function because the single input of 10 corresponds to two different output values, somewhere on that lines. And this is why we're practicing drill, 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 so that we get better and faster at it. Okay, so now we're going to talk about another characteristic of a function called a one-to-one function. I know, right? There's a lot of definitions. So just like a function was a relation, a one-to-one function has to satisfy the characteristic of a function first. A single input must correspond to, different inputs must correspond to a single output. However, in a one-to-one function, each output value corresponds to exactly one input value. So what this means is that now those single inputs in a function could correspond to the same output to be a function, but to be a one-to-one function, those different inputs must correspond to different outputs to be a one-to-one function. So when you take a look here, what tests do we use? So the vertical line test checks to see if a relation represented by a graph is a function. The horizontal line test checks to see if that function is a one-to-one function, right? So if any horizontal line intersects the graph more than once, then the graph does not represent a one-to-one function. And then we also have your turn, which I think I forgot to copy and paste. So let me go pause. Okay, so I'm having a little difficulty with this software, but it's fine. We'll just finish up as is. But number 55 gives you a graph, and it asks you to determine if this graph is a one-to-one function. And what you should illustrate here, well, to be a one-to-one function, you have to be a function. So if you draw one vertical line test, sorry, it's not straight, and you intersect here and you intersect here, then this relation is not a function because, so we want to practice with the because, right? It indicates that a single input corresponds to two different outputs. Therefore, it cannot be a one-to-one function. So I wanted to take a look at that. Now, the second component that I would like to finish up here on page 174, a toolkit of functions. Functions have names, and we want to practice those names, right? And we want to practice the function notation. So f of x equals c, meaning y equals c, that doesn't matter what x is, y is always going to be the same. That will give you a horizontal line, and it's called the constant function. F of x equals x is the generic basic function of a line called the identity function. So whatever your input is, your y output is the same, and you will get a line. Now, some functions, maybe you haven't been familiarized with it, but f of x equals the absolute value of x. And notice here that when you put values of x and you take the absolute value, your y values are always the same, and therefore you get a v. Notice that the graph's axes are labeled x, f of x, and I want you to get in the habit of labeling your tick marks because that's going to be important, because we're going to be graphing functions, a lot of functions, and if we don't understand their basic names, it's going to be problematic later. F of x equals x squared is a quadratic function, so whatever you put in for x, you're squaring that value to get the y values, and you get something here. The only feedback that I would provide for this graph is it doesn't have the arrows. So you see here the arrows, that's important, so you want to make sure you include that. And then we have our cubic, f of x equals x cubed. And then again, when you put an x value here, you raise it to the third power. And again, they're showing you what a table of values, and then they plot the graph. Then we have the reciprocal function, f of x equals 1 over x. So again, when you put your values of x, it's the reciprocal, so you're going to get this portion in the first quadrant and this portion in the third quadrant. And then we have the reciprocal squared, where we have 1 over x squared. And so therefore, when you put your x value in and you square it, you get positive. So that's why this portion came up to the second quadrant. And notice here, again, feedback to provide the arrows, because it says that your graph, the difference with not having the arrow says it terminates. The arrow says the graph goes on forever. And then we have our square root. Now we're going to be talking about the domain in the next section. So you cannot take a square root of a negative value. So therefore, that's why the value starts at 0. And then again, you take the square root of those x values to get the y. And again, you want to include the arrow. And then we have the cube root. And since we're able to take a negative, we're able to take the cube root of a negative value. That's why we get this portion here. So, thinking about this, and, we're going to start having drills that are going to be counting for points. It's quite fair and realistic that I could have a graph and then I could ask you to state its proper name. So we just want to make sure that we're drilling. And what's cool about this too, I found in your textbook that you also have other links to other videos if you need more detailed information. And now, we get into the practicing. These are the concepts we want to drill. I haven't focused on this one too yet, and between 8 and 26, but I'm getting there. Next video, we're going to talk about this difference quotient. We did that already.